Dear students, today we are going to learn about the chapter points and crossings of railway engineering. So today we are going to discuss about the necessity or requirement and what turnouts are and the important terms used in points and crossing. As before, I have already defined what points and crossings are. Still, I am going to repeat them. So, points, crossings, turnouts, crossovers, and such related terms are contrivances or arrangements by which different routes, either parallel or diverging, are connected and afford the means for trains to move from one route to another. I think you have understood this. So now, why we should provide, or we are going to discuss about the necessity or requirement of points and crossings. See, in case of roads, the facilities for turning of vehicles from one path to another do not require any special arrangement as the wheels have no flanges. The problem of diversion of trains from one track to another due to flange which are provided inside towards the track is solved by special arrangements known as points and crossings. So first of all, let's know why it is required. First, points and crossings provide flexibility or movement connecting one line to another. They also help for imposing restrictions over turnouts which necessarily retard the movements. Retard the movements with the movements moves towards a little backward. And also from safety aspect is also important as points and crossings are weak points in the track and vehicles which may cause derailment at some places. So let's now learn about what turnouts are. So first of all, let me define what turnout is. Turnout is the simplest combination of points and crossings which enables one track, either a branch, line or a siding, to take off from another track. So, the turnout is provide facilities for safe movement of trains in either direction on both the tracks. So, it will be easier for you. Let me explain it by showing you the diagram. This is the diagram of a left hand turnout. So there are different parts in a turnout which are used. So one by one I am going to explain what are the different parts of these turnouts. So first, this is the through switch. I am pointing it. This is the through switch, through off switch. Next, I have written all the alphabets regarding which I'll explain you later. Then it is this part is the end of stock rail. Previously in the terminology chapter, I've explained what these all terms mean. Next, it is the bend in check rail. It is the inner curve, the curve which is inwards, inward curve of lead rail. Then these we know, these are the check rails. This is wing rail here, and then this one is this part is the throat, and this gap is known as the flare. It's F-L-A-R-E, flare. Then it is the AB stock rail, AB stock rail, and this part is the stretcher bar. Again I repeat, this part is the stretcher bar, this line which I have drawn, this stretcher bar, and this, from this line we can say the distance from the trailing direction. This is the trailing direction, which I will explain it what trailing direction is. This part is the trailing direction and this part is the facing direction. I will explain you just a few seconds what these two terms mean. And this total path is the overall length of the points and crossings we are going to build. I am showing it again. This line and this line I have drawn. You can see the line which I have drawn, which I have marked as the facing direction and the trailing direction. These lines, these two lines, from where the check rail, wing rail end here and here the throw of switch, this total length is called as the overall length. Next comes, it is the outer curve, this of the lead rail. Then it is the CD tongue rail. Then here it is once again a check rail. It is this part. This part is the wing rail. And I'm explaining. I think this part was not clear. This is the wing rail. Then this part is the inner straight of the lead rail, inner straight lead rail, and this part is the outer straight lead rail. Then comes this end is theoretical nose of crossing, TNC, and from here the arrow mark given is the actual nose of crossing. I'm repeating again, the terms are theoretical nose of crossing, TNC, and actual nose of crossing, ANC. And this both distance is known as throat. See, the distance between actual nose of crossing and theoretical nose of crossing is the throat. Next I am going to explain you the terms used in points and crossing. First let us discuss about facing direction. What facing direction is? See, I have given here a arrow mark, means this direction is known as facing direction. So let us know what is facing direction. If someone stands at the toe of switch and looks towards the crossing, then the direction is called facing direction. I repeat, if someone stands at toe of the switch, here the switch is toe of the switch, and looks towards the crossing, then the direction is called facing direction. Next comes trailing direction, which is just in the opposite direction of facing direction. Trailing direction is if someone stands at the crossing, this is the crossing part here, at the crossing, and looks towards the switch. Where is the switch? In this direction. When someone stands at the crossing and looks towards the switches, then the direction is called trailing direction. Then comes what is facing points. Next terms comes facing points of turnouts. What is this? These turnouts are those where trains pass over the switches first and then they pass the crossover. Repeat, those trains when they pass over the switches first and then they pass over the crossing. These are important to specify when the direction of movement of trains is reserved for facing direction. Next, trailing points of turnouts. Trailing points of turnouts are those on the opposite sides of facing points. I previously explained that trailing direction is always in the opposite direction of facing direction. So these are important to specify when the direction of movement of trains is reserved for trailing direction only. Facing points was for reserved for facing direction. In trailing point turnouts, it is reserved for trailing direction only. So every point may be a facing or trailing point or both, depending upon the direction of movement of trains. Next, let me tell you what is right hand and left hand turnout. So this diagram is about left hand turnout. Again, I will show you the line diagram of right hand turnout. So let me explain what right hand and left hand turnout. If a train from main track is diverted to the right of the main route, from the main route, when it is diverted towards the right direction, facing direction, then this diversion is known as right hand turnout. I have already drew a line diagram of right hand turnout. See, you can see the difference. This is the right hand turnout and here it is the left hand turnout. If a train from the main track is directed to the left of the main route, see, it is the main route and the track is diverted towards the left direction. So when the track is directed to the left of the main route in the facing direction, then the diversion is known as left hand turnout. Now let me tell you what is right hand and left hand switches. Right hand and left hand switches. See, I have written here left hand switch and right hand switch. These are termed as left hand or right hand switch depending upon left or right when seen from facing direction. From the facing direction, when we see it, it is left or right direction, that is standard point, and look towards the crossings, then this part is known as left hand and right. From the facing direction, left hand and right hand switch is indicated or by facing the face, not from the trailing direction. Trailing direction, if you denote this one, then it may be alternate directions. So always towards the facing direction we decide which is the left hand switch and right hand switch. So again I am saying what is facing direction is, if someone stands from the toe of the switch, where is the toe of switch? This one. From toe of switch and looks towards the crossing, then the direction is called as facing direction. Again, trailing direction. Trailing direction, if someone stands at the crossing and looks towards the switches, then the direction is called trailing direction. Again, you can see here, this was the left hand turnout from the main route or main track when the train was diversion from towards the left side, then it is called as left hand turnout. And again I have drawn here a picture of, see, the track and the diversion is towards the right hand side, so it is the right hand turnout. Here I tell it is I already told you left hand switch, this is the right hand switch. Here are the check rails. See again, here will be the switch, as it is the line diagram. I have not written this previously, but if this is the throw switch, then according to the definition, what if the toe of switch, we stand on the toe of switch and face towards the crossing, then it is the facing direction. So this is told as facing direction, and this is the trailing direction. And these are the check rolls, as the track is towards the left hand. If a train wants to divert its directions towards right, then he this type of turnouts are built. Next, these were the two tracks, left hand turnout and right hand turnout, which are diverted from the straight track. And now when both and this is the diagram of turnout from curved main track. These tracks were straight track. From straight track we have turn a bit curved track, but from curved track we can also make again a turnout, curved main turnout. So this will be the facing direction. So obviously here will be the throw of switch. Again, here are the check rails. This is the turnout of main track, and this one is the turnout of main track. These are again the check rail. You can see the difference. Here we have drawn the turnouts from the straight track, and again here we have drawn from the turnout from the curved main track. These tracks are curved, and here in both the diagrams the main track are straight. So these were the some terms which are discussed about the different types of turnouts. Now, what will be the working principle of turnout? The principle is one turnout provides facility for the principle of a turnout is one turnout provides facilities for turning off vehicles from one direction only and not from both the directions of the straight path or route as in the case of roads. So on which principle are the turnout being built? One turnout provides facilities for turning of vehicles from one direction only. It cannot happen like in roadways. We can turn the vehicle any sides we desire. So one turnout provides facility for turning of vehicles from one direction only and not from both the directions of the straight path or route as in case of roads. Next, let us discuss about what is crossing. So let me define it. A crossing is a device which provides two flanges through which the wheels of the flanges may move when two rails intersected each other at an angle. This one I have already discussed in previous chapters. So now let us discuss about types of crossings. So these are classified on the basis of shape of crossing, under the shape of crossing, first comes the acute angle crossing or V crossing. According to the shape, the name has given as acute angle crossing or V crossing. Next comes the obtuse angle crossing or diamond crossing. The third one is square crossing. Next, on the basis of assembly of crossing, the way it is assembled, first is spring or movable wing crossing. Next is ramped crossing. So on the basis of shape of crossing, acute angle crossing or V crossing, then obtuse angle crossing or diamond crossing, third one is square crossing. And on the basis of assembly, the way it is assembled, there are two types, spring or movable using crossing. Second one is ramped crossing. Now let us discuss what is acute angle crossing. This type of crossing is widely used. It is obtained when a left-hand rail of one track crosses a right-hand rail of another track or vice versa. See, according to the name acute, we can guess one thing. As we know, acute angle, you may have heard in geometry classes, acute angle is less than right angle and obtuse angle is greater than 90 degree and less than 180 degree. When I will draw the diagram, you will be a bit clear. I am drawing the as I'm drawing it. view may be a bit clear. So this is the RH wing rail. This will be the, if we take this as facing direction, this would be the right hand wing rail, and this will be the left hand wing rail. As it is the facing direction, this side will be obviously trailing direction. This part is the throat, and this part is TNC. As I previously told, theoretically, nose of crossing, it is ANC, actual nose of crossing. Then is the flange way, and this is the gap from ANC to the throat point. This is the gap, and this is the flare. This is the point rail. And this is the overall length. So this is a drawing of acute angle. You can guess this angle is, if we take this one as, so it is less than 90 degree, the angle, so it is named as acute angle. If the angle of intersection of the approaching rails, if the angle of the approaching rails is acute angle, that means less than 90 degree or right angle, it is termed as acute angle. It may consist mainly of point, spice rails, wing rails, check rails. Then let us next we can see about obtuse angle crossing. Obtuse angle crossing. So here the difference you can see, as above I have drawn acute angle. Here the angle is more than 90 degree but less than 180 degree. So this is the splice rail. This is the splice rail. Here is the complete diagram. Splice rail. This is the point rail. Here again it is the splice rail. It is the point rail. This is the running rail. And here we both can see here again TNC, theoretical nose of crossing, ANC, actual nose of crossing. This is also the TNC and ANC, actual nose of crossing. So if we draw the intersection line, this will be called as the elbow of intersection. So obtuse angle crossing is obtained when left hand rail of one track crosses right hand rail. See carefully, this crossing is obtained when left hand rail of one track is or crosses right hand rail of another track, or vice versa, at an obtuse angle, this angle, okay, at an obtuse angle. Here it is in acute angle crossing, this angle will be less than our 90 degree, and here the obtuse angle, it will be greater than 90 degree but lesser than 180 degree. In a diamond crossing, a pair of special crossing is used which is called obtuse crossing. This crossing is used in a diamond crossing. In case of obtuse angle crossing is long being there, do not carry the wheels, as in case acute angle crossing rather act as a check rail. Next comes the square crossing. Next comes the square crossing. I will just draw the line diagram of crossing. It will be in this shape. Geometric design will be just like as a square. This is just the line diagram of the square crossing. It will just look alike this way. When two straight tracks cross each other, at right angle 90 degree, they give rise to a square crossing. This type of crossing must be avoided on main lines because there is heavy wear due to dynamic loads, or we can say the main lines. These types of crossing may be used when there are less traffic on the tracks. So this is the line diagram of square crossing. When two straight tracks cross each other at right angles, they give rise to square crossing. So this was the types of crossing according to the syllabus. So further chapter will be discussed in the further videos. So thank you students.